Sudah ada 83 partisipan yang bergabung dalam sesi ini. Bu Aryani, apa kita mulai atau?
Oke.
Oke, Bapak Ibu sekalian, sudah jam 1:08, so maybe soon we will start this session. Oke. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. Salam sejahtera untuk kita semua. Distinguished participants, ladies and gentlemen, first of all, I would like to start by wishing you and your family my personal best for your health and your safety in this difficult time during a pandemic situation. But hopefully, this condition will keep us moving, to keep us working, sharing, and of course, caring to others, and of course, to our nature and environment. And secondly, I would like to welcome you to this special session of Forest and Forest Product Innovation Virtual Tour as part of the event of the 6th INAFOR, the International Conference of Indonesian Forestry and Environment Researchers of year 2021. So our theme in this 6th INAFOR is Greener the Future, Environment, Disaster, Resilience, and of course, climate change. So, distinguished participants, ladies and gentlemen, I hope this session is quite special because in this session we have 4 distinguished speakers that they will share their research results and their knowledge, and furthermore, they will take you virtually on their activities and also their research sites. And not only in Indonesia, of course, because we have 1 presenter speakers from Japan. So in this session, we will also have take you to Tokyo, Japan, to join with Pak Indra, Gunawan there. And yeah, so even in this pandemic, we will take you to Japan. Yeah, so it's I think it's very lucky for all of you to join this virtual session. So, distinguished participants, ladies and gentlemen, it is an honor for me to present here and to facilitating you to this virtual tour session of Forest and Forest Product Innovation. So let me introduce myself. My name is Desy Ekawati. Currently, I have been assignment as a project coordinator of bamboo agroforestry and industry development. It's a collaboration among the Ministry of Environment and Forestry, ICRAF, and also ASIA, Australian Center for International Agroforestry Research. So in this session, distinguished participants and ladies and gentlemen, as I said before, we will have four distinguished speakers. In the first presentation will deliver by Ibu Ratih Damayanti, Ph.D. She is the researcher from Center for Standardization of Sustainable Forest Management Instruments, and Dr. Ratih will present the Silarium bogoriensis at the development of automatic wood and identification system. The second speakers, there will be Bapak Insinyur Jamal Balfas, M.Sc, and he is a researcher also from the Center for Standardization of Sustainable Forest Management Instruments. And Pak Jamal will present the presentation about the most effective processing technology in converting oil palm wood trunk into panel. And the third speakers is Bapak Indra Gunawan, who will take us to Tokyo, Japan, to see the earthquake resistant design for timber structures in Japan. And last but not least, we will have Ibu Novitri Hastuti, Ph.D. She is a researcher from Center for Standardization for Sustainable Forest Management Instruments. And Ibu Novi will present the nanocellulose membrane for ethanol dehydration. So without further ado, ladies and gentlemen, distinguished participants, we will have our first presenters, Ibu Dr. Ratih Damayanti, to deliver her presentation. Is it Ibu Ratih is already in our rooms here? Yeah, I saw already. Yeah. Okay, Ibu Ratih, the screen is yours. Oh, I'm sorry. I would like to inform all the regulation or the time limit that we have. So each presenter, we will have 20 minutes. It's the presentation, including the video. And then we will have all presenter present all the presentation. And then in the end of this session, we will have the Q&A session. Yeah, Ibu Ratih, please, screen is yours.
Yeah, thank you very much, Mbak Desy. I'm very happy today. I want to share something very important for you all. But firstly, I want to show you the newest video of Silariums and also the Aiko Bailhaka is for the operators.
Yang ini koleksi bambu. Ada juga koleksi kayu fosil. Bisa lihat wajah kayu. Ini lab anatomi. Ada reading cornernya juga.
Semua, salam sehat, semangat, sukses. Jalan-jalan sambil tambah pengetahuan kita bisa kok. Nah, Tugu Kujang ini menandakan kita telah tiba di kota Bogor, yang berarti sebentar lagi sampai deh di lokasinya. Yeay, ini dia lokasi wisata ilmiah kita. Deket kan dari Jakarta? Ini adanya di tengah kota Bogor, tepatnya di Jalan Gunung Batu nomor 5 Bogor. Di sini adem dan seger banget udaranya karena ditumbuhi oleh berbagai koleksi pohon. Nah, jadi wisata ilmiah kita adalah ke Silarium bogoriense. Apa tuh ya? Ayo ikuti terus perjalanannya. Wajib patuh protokol kesehatan ya. Silarium bogoriense letaknya di lantai 3. Begitu masuk, kita dapat melihat galeri berbagai macam informasi dan produk. Ada peta Indonesia dari kayu, kepingan kayu berbagai jenis, dinding kayu, foto mikroskopis, dan juga informasi ilmiah. Inilah Silarium Bogoriense. Mudahnya kita sebut sebagai perpustakaan kayu, yaitu tempat koleksi berbagai jenis kayu dikumpulkan, dicatat, ditata, dirawat, dan disediakan bagi pihak yang memerlukan. Dengan dukungan berbagai pihak, pada 2018 lalu, prestasi membanggakan berhasil diraih. Silarium Bogoriense ini berhasil menjadi nomor 1 di dunia. Wah, keren ya!
Bu, jadi gimana Bu perjalanan Silarium Bogoriense menjadi nomor 1 terbesar di dunia?
Wah, itu ceritanya panjang, Mbak. Jadi perjalanan Silarium Bogoriense nomor 1 dunia itu merupakan sebuah perjalanan yang heroik, yang pada awalnya memang
technical problems. The operator will play again the video, or I can start my presentation. Okay.
Yeah, or maybe we can start with your presentation, Mbak Ratih, and then the operator will continue the rest of the video.
Okay, please. I want to share my presentations. Okay. Thank you very much. Yeah, unfortunately, we can't enjoy the video first because I'm also want to show many things about the Silarium. Perhaps you want to visit it sometimes. You already know the condition, the news condition of our Silarium. Ladies and gentlemen, thank you for your attendance here. And today I want to share about the Silarium Bogoriense and development of water identification system in Indonesia. In the video, you already heard that Silarium Bogoriense is the largest Silarium in the world, and it is already got a very long journey. Firstly, in 2018, we still in the positions of the 3rd or the 4th largest Silarium in the world, but then the college from the Ministry of Research and Technology challenged me why in the presentation is always at the 3rd or the 4th positions. How if Indonesia become the first or the largest Silarium in the world? At the time, I think it's very impossible. I said that, how about the second? But they said, no, to be the second, you will be nothing, but you have to be the best in the world. So yeah, we start to think how to reach that, how to gain to be the first biggest Silarium or wood collection in the world. So for the next slide, please. Today I want to show you Silarium Bogoriense and also the developments of wood identification system in Indonesia. This is our Silarium Bogoriense. The first Silarium, the only one Silarium in Indonesia that is established since 1914, already have 100 years age, and is already registered at the Index Silarium Institutional Wood Collection. It is very prestigious because in the Index Silarium Institutional Wood Collections, all 160 Silarium in the world registered that. And in the Silarium Bogoriense, we have the authentic wood collection. The authentic means that the identity of the timber is already authentically with the herbarium collections. And we have the form of a trapezoid, which is very unique one. It's only belong to Indonesia, this collection, and then also in the wood blocks, and also this. The moment Silarium Bogoriense collections already completed with the QR code. Next, please. Totally, it is more than 180 solarium in 60 countries. For example, in Australia, they have 8 solariums in each state, and then in Indonesia we only have 1. And then firstly, we become the if we combine all the solarium in Brazil, we will be the 4th or the 5th largest. But then in 2018, we did. I told you before. We try to collect as many as timber from the plantations, from the natural forest, from the academic forest. And then please next the slide. And then this is in 2018. You can see from the graphs in January, our collection is totally 45,000, but during 6 months, 6 to 7 months, we reach more than 125,000 specimens, which belong to the Dutch collection, and then we can reach as the largest solarium. And then it's already declared by the Minister of Environment and Forestry of President Jokowi on September 2018 in Jakarta, and also promoted in many places, including in the Katowice, Poland, in December 2018. Next, please. I want to show you, this is how the process to adding to add wood collections. We visit many places in Indonesia, from the east to the west, from the south to the north of Indonesia, in Medan, in the Bogor, and some place in Sumatra. And then next we can have quick select here, Samarinda, and then all the parts of Kalimantan, because Kalimantan has a big potential of wood in the forest, Palangkaraya, Tarakan, Surabaya, Bandung, Semarang. We did it only in 6 months. You can imagine how we try to collect or to visit all the universities, governments, forest-based industries, forest service, and also the research institutes in all of the part of Indonesia. And then next, and then in August, we got flood of timber going to the Siladong Bogores in Bogor. You can see here some of the students in University of Riau. They collect timber by themselves. They collect the branch, the stems, also from the East Java forest states. They send out trucks of timber, totally more than 50,000 specimens from the forest industries in Java, in East Java especially. Next. Yeah. This is the activities in many places. They send a picture. They show us. They take a part of this collection of this activities, how to collect as many as wood specimen. Also, but the authentic one, we also collect the herbariums, and then you can see how everyone here in a part of Indonesia contributes to the wood collection of solarium. Next. And then this is when we get the float of the timber, we open the parcels, and then we make it in the dry room, and then we sort it, we arrange them, and also verify the wood species. And next, and giving a code of its timber, its specimen. Next. This is we have 4 solariums. All of the place in all the rooms in solarium already full with timber, and then in the next couple months we try to arrange them to make a database of the new timber. And next, please. Yeah, before previously. A slide before. Okay, the benefits of solarium. one slide before this. Okay, yeah. Yeah, we also convinced us that what we did is very important. It's very important, especially for the wood science, because in the solarium we can do many things. Firstly, from research, for example, for the wood anatomy and basic properties, commercial timber classification as well, and also the new activities is development of wood automatic wood identification systems. And besides for the research, we also use solarium, automatic wood solariums for the wood identification for industries, and also for the legal and customs purpose. Timber here has become legal evidence because in the laboratory anatomy, we also accept the wood identifications testing. Next, please. Yeah, this is all what we can do in the solariums for the research. For example, for growings to predict future climate patterns. Yeah, we can have a quick slide for this, please. And then next is next slide. This is for the carbon sequestration, which is important for the climate change. And the next, yeah, this the wood collection here become the carbon storage, the huge carbon storage, to keep to minimize the carbon thing. And then next, please. And also to predict Indonesian emission factor, which is very important. It is important to have a national emission factor, and solarium can be used for the research. Next, please. All the journey of the solarium Bogorians can be already documented in the book with the language Perjalanan Solarium Bogorians and also the journey of solarium Bogorians. We already provided in the ebook. You can see from the year by year of the journey of the solarium Bogorians. Next. The solarium Bogorians become the data source for the development of automatic wood identification system, already famous with the name of AICO KLHK. The wood identification is one process in wood species determination for industrial, bioforensic, and research. Next. This is the standard method that we can use in the wood anatomy laboratory. This is the step. The step first we have to see the general observations, and then the observe the macroscopics by using the 10 times loops, and then the microscopic observation by using the microscope, and then we have to compare the authentic wood collection with the samples. You can see here, if possible, this is the macroscopic of plywood, and then this is the microscopic of the wood authentic. So we have to match 100%. So and then we determine the wood species. It needs a very long time for 1 to 2 weeks generally. And then next, because of the limitation of the existing science, technology, and human resource capacity, it makes that the wood identification can be undertaken by the experienced and practitioners or officers. And then our burden here is not tolerance for errors in wood identifications. So we, as a researcher in the wood anatomist, as a wood anatomist, we want to develop a system that can help everyone to identify, to understand timber. Next, please. This is the journey of what the AICO KLHK we start in 2006, but it's funded by our TIPA in 2011. We start with the 30 wood species, and then with the cooperation with LIPI and also with RISTEC, and then in 2018 we launched AICO, and then in 2019. The AICO KLHK is launched in the Play Store for free. Totally at times 823 wood species. And then in the 2020, we developed 2 language of our AICO KLHK, and completed with the imported timber and also the lesser known species. And then in this year, we added with the special timber that requested by the wood custom. Next. This is the face of AICO KLHK in 2019. And then next the next in 2020, we have a new phase of Aiko Kailhaka. Next slide, please. This is totally the users of Aiko Kailhaka already reached more than 3,500 users, personals, individuals, and also from the institutions. And then here in the wood library, you can search many information of timber, and then you can see here, this is the codes of the IUCN conservation status. So if you try to, for example, search one species and then it has a red code, so it means that the timber already vulnerable and so on. And then next. Yeah, this is the benefits of Aiko Kailhaka. First, of course, this is our objective. First, that we need to shorten the time in wood identifications, because the police, the custom needs very quick decisions to determine if the document is correct or not. And then we try to give more objective identifications, and also with the complete information. And then we need to have a portable and easy to use wood identification system. And next, and then the important thing is we want to enhance the accuracy of the legal documents in SPLK, because there is a request to have wood species name, botanical names in our legal. Next. And then we make cooperation with many institutions. So with RISTEC, LIPI, ITB University, SciTech Labs, and also Pitt University and US8. Next please. We try to develop many methods to facilitate wood identifications. This is some methods we already try, from the anatomical, computer vision, DNA with the IPB University, and also from Kailhaka, and also the laser-induced plasma spectroscopy with the EP research Center for Physics, and also near infrared with the Kyoto University and LIPI. And then the newest one, we have wood identification system based on the electricity. It's already patent this year. Next. This is the recent activities that we conducted in anatomy laboratory. We create ECVT for the dynamics with the cooperation with the US8, IPB University, and SciTech laboratory. So we try to make inside the living tree transparent. It is the effort for us to find where is the tree's brain. So if we can monitor what happened in the tree, so we can do many things there. For example, we can obtain for the engineering what kind of timber properties we need. And then also besides that, we still improve the automatic wood identification by using the electricity base, because the Aiko, we need some effort to use it. But we're using this device, we only to have a sensor to identify timber. And then also we develop an automatic identification for bamboo. And then the next improvement of Aiko Kailhaka is how we can defer the wood origins or the geographic location, and also determine the time where the trees are cut or carbon dating. We want to try to use the biodeterioration and oxygen isotopes approach. That's all. Thank you from me, from the Silarium Bogorians and team. Please come and visit Silarium Bogorians. Thank you.
Thank you very much, Dr. Ratih, for your informative presentation. And yeah, what a great achievement that Indonesia become the first biggest Silarium collection in the world. So hopefully we can keep this position as the first Silarium. So it's already 20 minutes, but Ibu Aryani, could we play again the video of Ibu Ratih? Yeah.
Yang ini koleksi bambu. Ada juga koleksi kayu fosil. Bisa lihat wajah kayu. Ini ini lab anatomi. Ada reading cornernya juga.
Halo semua, salam sehat, semangat, sukses. Jalan-jalan sambil tambah pengetahuan kita bisa kok. Nah, Tugu Kujang ini menandakan kita telah tiba di kota Bogor, yang berarti sebentar lagi sampai deh di lokasinya. Yeay, ini dia lokasi wisata ilmiah kita. Deket kan dari Jakarta? Ini adanya di tengah kota Bogor, tepatnya di Jalan Gunung Batu nomor 5 Bogor. Di sini adem dan seger banget udaranya, karena ditumbuhi oleh berbagai koleksi pohon. Nah, jadi wisata ilmiah kita adalah ke Silarium Bogoriense. Apa tuh ya? Ayo ikuti terus perjalanannya. Wajib patuh protokol kesehatan ya. Silarium Bogoriense letaknya di lantai 3. Begitu masuk, kita dapat melihat galeri berbagai macam informasi dan produk. Ada peta Indonesia dari kayu, kepingan kayu berbagai jenis, dinding kayu, foto mikroskopis, dan juga informasi ilmiah. Inilah Silarium Bogoriense. Mudahnya kita sebut sebagai perpustakaan kayu, yaitu tempat koleksi berbagai jenis kayu dikumpulkan, dicatat, ditata, dirawat, dan disediakan bagi pihak yang memerlukan. Dengan dukungan berbagai pihak, pada 2018 lalu, prestasi membanggakan berhasil diraih. Silarium Bogoriense ini berhasil menjadi nomor 1 di dunia. Wah, keren ya!
Bu, jadi gimana Bu perjalanan Silarium Bogoriense menjadi nomor 1 terbesar di dunia?
Wah, itu ceritanya panjang, Mbak. Jadi perjalanan Silarium Bogoriense nomor 1 dunia itu merupakan sebuah perjalanan yang heroik, yang pada awalnya memang kita sudah punya modal spesimen yang sangat berharga yang merupakan hasil dedikasi dari para peneliti kami sejak tahun 1915. Suatu perjuangan yang tidak mudah untuk bisa menjadi seperti sekarang ini.
Silarium Bogoriense ini sendiri sudah berdiri sejak 1914. Awalnya koleksi contoh kayu yang dimiliki dikumpulkan dari hutan di seluruh Indonesia dan dalam perkembangannya melakukan tukar-menukar contoh kayu dengan silaria di beberapa negara di dunia seperti Austria, Australia, India, dan Afrika.
Jumlah koleksi kayu pada saat ini sebanyak 232.020 spesimen otentik dari 6.679 jenis kayu. Hal ini juga telah diakui oleh International Association of Wood Anatomists atau IAWA, dan tidak hanya koleksi dari Indonesia, kita juga mempunyai koleksi dari luar negeri sebanyak 2.632 spesimen.
Wah, ternyata Silarium tidak hanya punya koleksi kayu loh. Di Silarium ini kita bisa melihat berbagai jenis bambu dan juga rotan yang merupakan hasil hutan bukan kayu Indonesia. Keren kan? Mengumpulkan koleksi kayu tidak gampang loh. Mulai dari proses pencarian jenis kayu ke lapangan, pengiriman, pemotongan, pembentukan sampel kayu, otentifikasi, dan penyimpanan. Koleksi sampel kayu otentik di sini disimpan dalam bentuk yang unik. Ada yang berbentuk lempengan dan yang utama adalah berbentuk koleksi trapesium. Bentuk ini menunjukkan 3 penampang kayu yang berbeda dan memiliki karakteristik penting untuk identifikasi kayu.
Nah, ini dia yang bikin saya penasaran dari tadi, melihat wajah kayu. Kira-kira seperti apa ya?
Wah, ternyata seperti inilah wajah kayu. Unik ya? Database yang terdapat di Silarium Bogoriense tersimpan dengan rapi pada sebuah server. Ini memudahkan kita untuk mencari dan mendapatkan berbagai data dan informasi dari koleksi kayu yang diperlukan. Apalagi pada tahun 2020, database ini telah dimutakhirkan dengan mengkombinasikan QR Code. Jadi, pencarian akan menjadi lebih cepat. Data dan informasi yang ditampilkan sangat komplit. Kita bisa tahu jenis kayu dan nama botani atau nama ilmiahnya, bahkan informasi tentang kegunaan kayu tersebut. Jadi, jelas sudah fungsi adanya Silarium Bogoriense ini. Selain untuk mendokumentasikan kekayaan sumber daya hutan Indonesia, juga sebagai rujukan utama dalam pengembangan iptek anatomi, sekaligus sebagai tempat kita belajar. Di sini, selain melihat koleksi kayu, kita bisa belajar memahami karakter kayu dari struktur anatomi atau sel-sel penyusunnya. Dari struktur anatomi kayu ini, kita bisa memprediksi sifat kayu untuk menentukan kualitas sekaligus kegunaannya. Berawal dari koleksi kayu Silarium Bogoriense inilah, akhirnya juga dikembangkan pelayanan pengujian identifikasi kayu sebagai satu-satunya layanan uji identifikasi kayu yang telah terakreditasi ISO. Nah, ini yang membuat berkunjung ke Silarium Bogoriense menjadi istimewa. Kita disuguhi dengan sarana pengetahuan ilmiah berupa koleksi kayu otentik dalam rak-rak kayu unik. Sampel kayunya berbentuk trapesium yang tertata rapi. Juga ada koleksi sampel kayu duplikat dan hutan tanaman. Kita juga dapat menikmati audio-visual iptek hasil hutan. Dan dengan adanya Reading Corner, kita bisa membaca berbagai buku menarik tentang kayu. Belum puas? Tenang, kita bisa santai sejenak sambil menikmati galeri produk kayu. View pohon-pohon ditambah semilir angin bakal membuat kamu merasa nyaman ketika berada di sini. Selain itu, Silarium juga menampilkan sisi lain dari kayu, yaitu koleksi fosil kayu berbagai jenis. Fosil kayu adalah kayu yang telah berumur puluhan, bahkan ratusan tahun yang telah membatu. Wow, ternyata fosil kayu tuh seperti ini ya.
Di sini tuh nyaman banget, kita bisa belajar sambil menikmati udara sejuknya. Kita patut berbangga juga nih, Silarium Bogoriense menjadi yang terbesar di dunia. Lalu terobosan barunya apa lagi, Bu?
Ya, masih panjang, Mbak. Jadi selama ini kegiatan identifikasi kayu hanya dapat dilakukan oleh peneliti atau petugas yang sudah berpengalaman. Bagaimana caranya proses identifikasi ini dapat dilakukan oleh orang-orang yang mereka tidak perlu belajar bertahun-tahun di bangku kuliah untuk tahu mengenai anatomi kayu, mengenai bagaimana cara identifikasi kayu. Nah, kami melakukan terobosan dengan membuat yang namanya sistem alat identifikasi kayu otomatis, atau kita sering dengar dengan nama AIKO KLHK. Itu adalah suatu upaya dari kami bagaimana proses identifikasi ini dapat dilakukan secara cepat, mudah, akurat gitu ya. Dan juga dalam waktu yang tidak lama, karena selama ini kalau kita lakukan di lab itu bisa sehari hingga 2 minggu kayak gitu. Tapi dengan menggunakan AIKO kita bisa melakukan identifikasi dalam hitungan detik.
Indonesia merupakan negara yang sangat kaya akan jenis tanaman hutan. Untuk itu, keberadaan Silarium Bogoriense ini amat penting sebagai sarana penunjang penelitian ciri anatomi dan taksonomi tumbuhan berkayu. Wah, asik dan keren banget ya tempat ini, Silarium Bogoriense. Selain semakin kenal dan tahu, kita juga makin pintar tentang kayu. Ayo, datang berwisata ilmiah ke Silarium Bogoriense.
Silarium Bogoriense.
Selesai sudah perjalanan saya di Silarium Bogoriense ini. Semoga memberi manfaat bagi teman-teman semua ya. Jangan lupa untuk selalu mencintai Indonesia dengan mengenal dan melestarikan kekayaan alamnya. Salam sehat, semangat, sukses. Bye!
Thank you very much for the video. It's quite interesting. It's very interesting video that might be encourage all of you to visit us here in Silarium Bogoriensis, especially the participants that not from our institution. So yeah, you can visit this Silarium as well. Of course, with we have to follow the health protocol. So, ladies and gentlemen, please apologize that in the first session, I forgot to introduce more detail about Dr. Ratih. So, please, committee, could you operator? Yeah, this is the background of Dr. Ratih. So, she was born in Jember, and yes, her background is relating with the anatomy and dealing with the wood anatomy and also all the aspect of research. Thank you very much once again, Dr. Ratih, for your wonderful presentation and also the informative video that take us to the Silarium, the first word collection in the world of the woods. Okay, distinguished participants, ladies and gentlemen, now we are moving to the second topic of our virtual tour session today. We will have Bapak Insinyur Jamal Balfas, M.Sc. So Bapak Jamal will present the topic of the most appropriate processing technology in converting oil palm wood trunk into panel as maybe as a substitution into wood. So Bapak Jamal, you will have 20 minutes, including your video show. Yeah, the video show will be shown in the end of the presentation. So before you start your presentation, here's the background of Bapak Jamal. Jamal Balfas, born in Bogor, and get the Master of Wood Science from the ANU, Australian National University, and also the Ph.D. In Wood Science, University of Melbourne, Australia. So this is the background of Bapak Jamal. So Bapak Jamal, please, the screen is yours for 20 minutes. Thank you.
Okay, thank you very much. Ibu Desy. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon, ladies and gentlemen. I would like to share the result of long research about oil palm trunks conversion into useful products. Next, please. Yeah, this is the outline of presentation. Next. Here we have all know that the oil palm plantation and industrial development of this commodity is very important to Indonesia, has become a national agenda. However, in the last few years, this program is agitated by several negative issues about forest deforestation, I mean the depletion of forests, and also leading to a palm oil boycott in international market. So this is a serious situation that we are facing in the last few years. Next. This is the one way of releasing the pressure of the oil palm business. The log extraction, we have about 500,000 hectares of oil palm replanting annually. So this will produce about 100 million cubic meters of wood trunks per year. So through research and development, we can produce several commercial products, and further promotion will leading to a substitution of the effective materials, so we can decrease the forest exploitation, meaning reducing the pressure of natural forests. Next, this is the potential of oil palm trunk during replanting. It's got about 200 cubic meter per hectare of the wood. So this is the huge amount of material that we can use for the new or the conversion of the conventional wood. Next, see that the distribution of material we can see in Sumatra, Java, Kalimantan, Sulawesi, Maluku, Papua, and all part of the countries. However, we can see here that the concentration is in Sumatra and Kalimantan. Next, this is the characteristic of the wood, oil palm wood. We have distribution of density of about 200 to 500 kilogram per cubic meter. The outer part contains higher density of wood, but going to the inner to core, this part of the denser wood is decreasing. And we look at the other part from bottom to top. The bottom contains the large part of high density of wood, and going to the top portion, this decreasing the density of the wood. Next, we can allocate the wood density uses. The 200 kilogram per cubic meter wood we can use for blockboard, flush door, and energy. Then going up to the 600 kilogram per cubic meter, we can use for construction, flooring, LVL, and furniture. Next, we see that the major portion of the oil palm trunk contain low density tissues. So we have to modify the wood to improve its performance. We can use wood densification or resin impregnation. Next, this is the characteristics of wood oil palm after modification. We can control the high moisture content of the wood. Irregular density of the timber can be adjusted, and irregular structure could be managed to be homogenized, and the decayable of this wood can be improved into more than 30 years resistant, and some other improved characteristic. We can easily work the wood and could improve the machining quality, and we could economize and make it more practice. Next. So the potential uses of oil palm trunk is for solid wood product, particularly woodworking and construction, and panel products we can use for plywood, LVL, blockboard, and jointed boards. Next. We have trial results. We can see further in the video. We can produce doors and flooring production. It's got unique appearance comparably the comparable quality with the commercial timber, and lower productivity and higher production costs. This is the problem that we have to overcome. And indeed, we have done several experiments to overcome this problem. And we also produce plywood production. We also research the plywood production and LVL, which are producing comparable quality, lower productivity, and higher production cost. This is also the problem that we have overcome in the last few years. Next. This the socio-economic benefits of the utilization of the oil palm trunk. We can increase productivity of 12 million farmers because they could get the income from selling the trees, the old trees, which is replanted. We can generate the new workplaces, new workplaces of approximately 420,000 workers, and we can increase farmer income by, say, approximately 10 million rupiah per hectare. And we can create new income and potential export earning for new devisa. Next. The environmental benefits of using the oil palm trunk: we can reduce pressure on the natural forest. We can storage carbon, which sinks approximately 28 tons carbon per hectare, reduce global warming, and reduce risk of insects and disease. Next. This is the carbon accounting on oil palm trunk use. We have some 14 million hectare of oil palm plantation currently, and the replanting on 25-year-old is approximately produced 220 cubic meter of oil palm trunk per hectare. And the carbon storage due to OPT use, we can have 28 ton per carbon per hectare. This is the result of research by Siswoko. And replanting 500,000 hectares per year, we can have 14 million ton carbon per year. This reduction emission per year is about 14 million ton carbon, or equivalent to 51.34 million ton carbon dioxide. Next. This is the oil palm plywood that we produce through the research. Next. This is oil palm flooring, which unique appearance of the oil palm trunk. Next. This is doors produced from the oil palm wood. Next. We got to the conclusion. So the plywood and laminated panel made from oil palm trunks are the most potential commercially wood product. So the panel product from oil palm trunk may substitute a large volume of timber traditionally obtained from the natural forest. Wood products from oil palm trunk are able to sequester carbon dioxide directly and indirectly for a better environment. Energy products from oil palm trunk may reduce consumption of fossil fuel or reduce greenhouse gases. That's all. What next? Thank you very much.
Thank you very much, Bapak Jamal Balfas, for the presentation. So is quite promising for the as a substitute for the wood product. Yeah. And next we will have the video of the process and the activity of the oil palm panel products.
Oh, can everyone see the screen?
Yes,
Okay.
but would you please to turn into the preview?
Sorry.
Mode?
Like this.
Yeah,
Is it okay?
yeah, it's okay. It's done.
So, okay, so my presentation probably it's a bit different with the other researchers. So it's like a bit from different point of view. I will try to present the forest product from the structure or construction point of view. In here, my presentation is about earthquake resistant design for timber structure in Japan. Okay, so first, let me start. Here is my current company. Then
it all started with our genuine desire to build stronger and safer buildings, cities that will not suffer from natural disasters, and a new type of society. Our starting point is always this genuine desire. We seek optimal solutions that can fulfill this desire and face challenges from every angle. Today, we are an engineering consulting firm with personnel from various backgrounds. We always seek optimal solutions to open new paths. We are Kozo Keikaku Engineering.
okay, so Kozo Keikaku Engineering is my company. I have been here for 5 years. So in Kozo Keikaku Engineering, is in English it's called like structural planning engineering, but actually it has 4 lines of business. Basically, it's like decision making support. We are predicting human behavior based on engineering. We are optimizing the shipping company, and then the second also we have the line of business in information and telecommunication. We build a comfortable network society through advanced IT technology. And then we are also supporting the production, manufacturing using computer simulation. And the last is my field. It's the construction and disaster prevention. We are designing a safe and secure society that can survive disasters. So this is my agenda. And this is me. I'm Indra Gunawan from Indonesia, Cianjur, 7 October 1992. And then my interest is about the timber structure and the steel structure, RC structure. And of course, in Japan, we are also learning the earthquake engineering as well. Okay, I will start by introducing why the structural engineer is so important. So structural engineers will be correlated with building. So we need to design the building in the cost that already fixed by the owner by using the material that available in the country, such as in Japan, in maybe RC or steel or also timber, and using the most simple structure construction. And then we also correlate with architect, contractor, and designer. Also, we are using the technology like modeling software, and also in Japan, because there is so many earthquake, we are using also base isolation and damper. Later, I will show how base isolation and damper is very important for the earthquake resistant structure. And then this is our enemy. So this is the loading for the structure itself. There is like wind, earthquake, tsunami, and soil. So the structural engineer is very important, because when earthquake comes, actually, if there is no building, earthquakes don't kill people, but buildings do. So the structural engineer need to make the design properly, so the disaster will not kill people. Why is structural engineering is very important in the world? So in here as well, I show the world earthquake map, and every 10 years there is so many big earthquake, and even in Indonesia also in 2004 there is Sumatra earthquake, has the magnitude of 9.0, and then so many earthquake in the Ring of Fire. And then in this map there is you cannot see Japan Island, I think, because Japan Island is already covered with the red dot around here, because so many earthquake here. And when we zoom the Indonesian earthquake map, we can see in here there is so many earthquake in Indonesia as well, like Jawa, Sumatra, Jawa, Maluku, Sulawesi, until Iran. Almost there is no severe area, but only Kalimantan there is a bit less earthquake. Maybe that's why the Jakarta Mini will be moved to Kalimantan. Okay, but structural engineer also has the weapon to fight the earthquake. In the structural engineering, basically in the world, we have three types of the structural resistant design. First is the resistant. In Japan, we call it taising. And then also damping structure, we call seising. And then isolation, it's called mensing. For resistant structure, basically we fight the earthquake energy by the strength of the structure. So strength versus strength. But for damping structure, we absorb the energy of the earthquake. And then, but the remaining, we fight with the strength of the structure. But for isolation, basically we separate the building from the soil. We usually use the very less rigid material such as rubber to separate the building and the soil. I will show you like the simple application for the damper and isolation. Because in Indonesia, I think there is still so many resistant structure only, not damper, but not isolation as well. In here, there is my current project that using in the left-hand side, the building is not using the damper, but in the right-hand side, the building using the damper. Then we can see the difference when the earthquake comes. In the first step, the displacement is almost same, but in the long-term side, the building using damper has smaller displacement. We can see the effect from the damper in this video.
Halo Pak Indra.
Will not drop easily.
Oh, ya, okay.
Sorry, can everyone hear the sound of the video?
No, I think there's no sound right there.
There is no sound. Okay,
Yeah.
I will try to. Okay, can everyone hear the sound?
Yeah, it works now.
Okay, so the second video is about the base isolation. In here, we have a pedestal that has the base isolation below it. So, and then we put two dolls here, the Daruma dolls, above the pedestal, and below the pedestal. Of course, the above the pedestal will have the effect of the base isolation because we separate it to the base. And then in the sound, sorry, I will repeat. Okay, it start moving, and then suddenly the doll attempt the base isolation and fall immediately, but the doll above the base isolation still safe. And we can see the movement of the pedestal also smoother than the base one. So, okay, I think it's enough here. So structural engineer is using, in Japan, we are using some kind of like the equipment to resist the earthquake. And then why timber structure is very important right now. The world has like the sustainable development goals. We need to reach goals because we also know there's a global warming, right? And CO2 is always increasing year by year. But by using the timber structure, we can use the carbon dioxide in in the world. So in sustainable development goals in our field, we are fighting in number 9 and number 11. That's why in my company also we want to make the sustainable environment by using the wood as the material for the structure. By using the wood as natural, renewable and sustainable material for building lighter carbon footprint and steel or concrete, we can use and remove the 21 million tons of
I think we lost Indra. Maybe there's a bad reception.
He's still here, Ibu. Indra.
Huh? Okay, you still here, Indra?
Oh yeah, I'm here.
But
sorry, I
lost
think the
your
connection
screen.
is lost.
Yeah, we lost your screen. So.
Okay, so I'll share my screen. Sorry. We'll start.
Indra?
Bu, bisa dengar saya?
Yes, we can hear you. Bisa. Is it possible to?
Kayaknya koneksi saya agak jelek Bu di sini.
Okay. But how about your presentation? Is already nearly finished, or?
Okay.
You can.
I will fix the connection.
Sometimes it happens when you're using Wi-Fi, or you're using the LAN cable, or you're using one Wi-Fi.
Bu Desy.
Yeah. Okay.
I think it's already connected. I'm sorry so much.
Okay. You will continue your presentation?
Okay, I will continue my presentation.
Okay, please.
Yeah, I will share my screen again here. And
yeah, I think this part, white timber structure.
Yeah, this part. This part. Okay, so sorry everyone, I lost the connection. So I'll continue my presentation from here. So the world also has like the sustainable development goals, because every year the carbon dioxide in the world always increasing, and then we also have global warming. Maybe we also can feel in Indonesia it's become hotter by year, and then so in my field we are fighting in number 9 and number 11. So we are also make the alternative for the materials for the building using the timber right now. And then why we are using the timber? Because timber has merit such as the timber is a sustainable material. And then the second is the timber is the natural insulator, so we can feel more colder in the timber structure. And then also timber is lightweight material. It's so in Jamal presentation also it's shown that the timber is only like around 500 kilogram per meter square per meter cubic. compare with the wood, compare with the concrete, it has 2,400 kilogram per meter cubic. And also it's prefabricated material, so it can be prefabricated in the factory, and then so in the site construction, it will be faster. And then in engineering woods as well, in Japan, we have like two types here. I will show you two types here. First is also common in Indonesia, GLT, but I want to share it's about CLT. In CLT, it's abbreviation of cross-laminated timber. In the GLT, it's all in the one parallel direction. We know that the wood is very strong in parallel direction of the fiber, but it's weaker than in the perpendicular direction of fiber. So the idea is to make the perpendicular direction of fiber, so the wood will become stronger in each direction. And in Japan also, we can make the CLT like this big. In here, it's around, I think, 10 meter round of the CLT panel. And then we can make the building something like this. So, but the structure, why people is using the RC and steel structure so much than the timber structure? Because in the structural engineering as well, in the concrete structure, we can make a rigid connection easily. So without using any brace or any wall in the steel structure, it still can be safe during the earthquake. But in the timber structure, it's only pin or half rigid. It's very difficult. So we need the wall or we need the brace to resist the structure, to resist the earthquake. In this video, I will show you like the frame structure without any wall, and then we can see so big displacement.
タフトの50回、3、2、1、過信。
You can see that the structure is easily displaced due to the earthquake excitation from the base. The second, we put the wall inside the portal frame. Then we also looking for the displacement in the portal frame.
では、過信を行います。タフト50回、3、2、1、過信。
But it's more rigid because some forces it's already taken by the wall. And in long term as well, if the structure is has lesser displacement as well. And then not only wall, in this experiment also we are using the oil damper here, and we can see the effect from the oil damper to the portal frame structure. You can see that the here, and the structure is becomes so displacement also becomes smaller. Okay, so we are knowing that the wall is very important to resist the structure from earthquake in Japan. So in Japan, there is a simple rule to calculate the required wall panel for simple structure. So even the worker on site also can calculate how many wood panel is required for the structure. In here, I will just show one of the simplest calculation, but just the disclaimer is the rule is based on Japanese architectural design law. So please not apply in Indonesia directly. We need to consider it before. So in Japan, like there is like 15 and 29 here for 2 stories of building. The number here is means the required wall length for each meter square of building. So such as if we have in the second floor, we have 100 meter square of the building area. So we need the 15 times 100. It means 1,500 centimeter. It means 15 meters of wall. But we also can reduce the meters of wall by using the stronger brace or wall panel, such as like this this brace has point of 1.5. So we can reduce 15 meter of the wall by 1.5. So we just need 10 meters of the simple brace like this. But if we are using the cross brace, the point is 3. So we can divide by 15 by 3. So we only need 5 meters of wall, something like that. So it's really simple. Maybe in Indonesia, if we can make some kind of this rule, we can also make the earthquake resistant structure in many provinces in Indonesia. But also the developer also increasing the wall because they are worried a big earthquake will come. So they are increasing by 1.25 or 1.5 times here. Okay, I think it's enough for the earthquake resistance timber structure. Next, we'll just show the project example. It's for the CLT core method development. We are using CLT to make like not only housing, but of course the office and then also shopping mall that has a core and then 3 column area. Then this one is like the video. Then also not only housing, we are also making the bridge as well. We know that traditional bridge in Japan using wood and then something like this. And then the result is like this. We are designing and observe in the site construction as well. And then this one is using the CLT panel. We are making the school for people. And in this project, we are using the building information model. We make the 3D model in the software, but not only 3D model here, we also can see the detail of the building, like the connection inside. We can see whether the connection is already in position or not. Then we're also doing the experiment for the wall panel. And then next also, this one is for dormitory. So using CLT panel also, we can make 12 meter of roof panel. So it's easy to construct on site. Then for the last, I think it's still new. And here the initiator is my friend is Takumi Noda-san. The idea is to scan the forest by Navivis. So we are also providing Navivis. So by scanning the forest, we can identify the properties of trees using image data. So maybe it's also interesting hearing the Dr. Ratih presentation, want to identify many wood properties. So the idea is also here from our companies, the idea is to scanning the forest and then by the image data, maybe we can identify the properties of trees and then also can optimize the size of the column for the construction. Okay, sorry, I think it takes a long time because there is the connection problem as well in the middle of my presentation. That's all from me. Thank you very much.
Thank you very much, Pak Indra. I think it happened when we do the online Zoom. Sometimes the connection is very bad and a trouble. Yeah, there's a very interesting and informative presentation, and I think this research is very important as well as in Indonesia, as you mentioned, that we are living in the ring of fire, and we know that nowadays the common building in Indonesia we're still using concrete, but actually our ancestor is teach us about the local wisdom. That's how mostly the traditional house in Sumatra, for example, is made from wood or bamboo and using the construction that adapted to the earthquake that might be happen at that time. Okay, once again, thank you very much. For ladies and gentlemen, distinguished participants, now we are moving for the fourth speakers. Last but not least, we will have Dr. Novitri Hastuti here. And could we have the background of Dr. Novitri? Dr. Novitri will present about nanocellulose membrane for ethanol dehydration. Is her research on I think it's also for her doctoral degree, Manofi, for this research, but she will tell you more about this topic. So as we can see here, Dr. Novitri graduated from the Agricultural Sciences Graduate School of Bioresource and Bioenvironmental Science Faculty of Agriculture in Kyushu University, Japan. So yes, Manofi, the screen is yours.
Okay, thank you very much, Desy. Good afternoon, distinguished audience. This is my turn, the last presentation, but hopefully you are still excited to join this session. The previous presenter, Dr. Ratih, already presented about her diligence to bring Indonesia to have a largest silarium in the world. And the second presenter, Mr. Jamal Balfas, he has presented about his masterpiece from the oil palm transportation, and also as well as Mr. Indra for a very inspiring and interesting presentation from Japan. Today, I would like to share about a part of my work in nanocellulose, particularly when I did my doctoral course in Japan, entitled Nanocellulose Membrane for Ethanol Dehydration. Next. Okay, I will start with the introduction, what is cellulose, or how to get the cellulose, and how can we convert cellulose into nanomaterial or nanocellulose. For you that you have been studying about forestry or wood materials, maybe all of you already familiar with cellulose, but for the audience who have no background academic in forestry or a little bit not very familiar with cellulose. So I will explain the first slide with what is cellulose. Okay, next. If when we look at tree, and we can see that a tree composed of plant cell walls. And if we look deeper inside in the cell walls, so there are any fibrils, microfibrils, and these microfibrils are from the three major components. They are lignin, cellulose, and hemicellulose. And if we try to peel off one sheet of fibrils, so we can see the cellulose assembly in 6x6 lattice, and we can find the cellulose in the linear chemical chain structure. Next. So how to get cellulose? We can extract cellulose from woody materials as well as from the non-wood timber materials. And first, we try to chop the materials into smaller pieces, and then we can do the pulping by chemical process to get pulp or cellulose. Maybe from this pulping process, we cannot get the pure cellulose. We only can get the 100% of cellulose from cotton, but by chemical treatment, we can remove the residual lignin or cellulose. From several reference, normally or generally, pulping can be done by soda pulping, kraft pulping, and sulfite pulping. Next. Then how to convert cellulose, the macrofibers in the macro size, to nanocellulose into nano-size material. But generally, we can convert the cellulose into nano-size material by chemical treatment using strong acid, such as sulfuric acid or hydrochloric acid, and also phosphoric acid, maybe it also possible. And this chemical treatment try to break the glycosidic linkage between the unit of glucose, and then by the assisting of mechanical disintegration, we can use in this presentation. I saw you via sonication or a blender to disintegrate the cellulose into the small pieces to get the nanocellulose. Then to remove some undisintegrated fibrils, we can use centrifugation to remove some impurity, as well as dialysis membrane to get the cellulose or nanocellulose in a higher purity. Normally, by chemical method, we can get the nanocellulose in aqueous form. And if we put it on freeze drying machine, we can get the wet and dried nanocellulose. Next. So, Isoge Sensei from Tokyo University, he had developed the method to extract nanocellulose using tempo oxidation. Tempo is one of chemical reagent. Maybe you can Google after this presentation. The acronym of tempo is quite long. But basically, this method can convert the hydroxyl group, primary hydroxyl groups, from the native cellulose into carboxylate groups using tempo-mediated oxidation. Then we can see in this picture, the macrofibers of our pulp can be converted into very individual nanofibrils in the nanosize particle, and the nanocellulose produced by tempo oxidation normally denoted as tempo oxidized cellulose nanofibrils, or we can shortly mention it by TOCN. Next. So one of my work to make a membrane from nanocellulose, I reacted the TOCN with the sodium alginate using water as a solvent in continuous stirring, and then we use the calcium chloride as cross-linkers, and we case the solution in the Petri dish, and we can get the dried and a very high translucent membrane, and we can use it for various purposes. But in this work, I tried to use this membrane instead of ethanol dehydration. Next. So this is the ethanol dehydration set. So the membrane we put in the glass filter, and also the glass flow pipe. We put the membrane over there, and then we apply the pressure in the certain pressure to move the ethanol solution. In this work, I use 80% of ethanol solution and 90% of ethanol solution. Then the liquid will be moved after the pressure applied to the container, and then we can see the performance of membrane in capturing the water molecules by a Kalb-Fischer detector to observe the prior the experimental and after the experimental. Then we can observe whether the nanocellulose suppression of nanocellulose can help to reduce or dehydrating the ethanol. Therefore, the water content will be smaller. Next. So there are 5 types of membrane that were tested in ethanol dehydration set. I made 5 membrane, and all of membrane we observe the performance, and also we compare with the commercial membrane. I use PT-FA membrane, and the TOCN that we use in this experimental not only self-made TOCN, so I made the TOCN by myself, but also the commercial TOCN from Nippon Paper Company. That's why in Japan, the research of nanocellulose has been developing very fast than other countries, because in industry they already produce the commercial nanocellulose in form of TOCN. Next. Then this is the results based on the experimental in several replications. The presence of TOCN, as I mentioned before, the method was convert the hydroxy group into carboxylic groups, and we know that these anionic carboxylic groups are responsible to absorb more water molecules. Therefore, the water content of ethanol solution can be reduced. And the presence of commercial TOCN and also my TOCN made by myself can increase the flux. Flux is the transportation of the liquid passing the membrane. And then if we use the fully TOCN membrane, the performance is quite very different. So the flux very low. Therefore, we can conclude that in using nanocellulose membrane, we still need some additional chemical reagent to be reacted with the nanocellulose and form the pore structure that we would to test in the serial of ethanol dehydration set. Next. And the water content after we pass the liquid or ethanol solution passing the membrane, so the water content can reduce compared to the initial water content. It based on the Karl-Fischer titrator. So before doing the experiment, we determine the water content in the solutions, and after collecting the solution, we measure again the water content. After doing the ethanol dehydration test, we measure again the water content and we compare whether any distinction or different regarding with the moisture content or water content in the ethanol solutions. Next. So currently the nanocellulose research very interesting topic maybe in developed countries and as well as in Japan. So the carboxylated nanocellulose such as tempooxidase cellulose nanofibrous can be used as a bioadditive scaffold for cell culture, and also we can use the nanocellulose for wood coatings to protect the wood quality or the wood for wood preservation. It is possible. And then also the membrane that we can make from the nanocellulose, we can use as a super absorbent for water remediation. Next. The other potential use of nanocellulose, I'm sorry, the one slide before, please. Okay. The potential use of nanocellulose also can be applied in biomedical applications such as for drug delivery systems and also in smart packaging. Now the one of my work is applying the nanocellulose for smart packaging in collaboration with Bogor Agricultural University. Next. And several reference, they already observed or investigated about the potential use of nanocellulose as enzyme immobilizer. In this presentation, I show you about the lacase immobilization and as well as the potential of nanocellulose as bone regeneration. So there are many various applications that can be applied by using nanocellulose. So I can say maybe the nanocellulose is our future because it can replace the fossil-based polymers that it more difficult to renew compared with the cellulose. But however, we still facing several limitation in the, what can I say, the tools or the apparatus, but in our office, in a Center for Standardization for sustainable measurement instrument, we have several tools or apparatus that can support the research of fiber or nanofibers. Maybe that's all my presentation, shortly about the potential use of nanocellulose, particularly in ethanol dehydration tests. And I have one video. Maybe you can enjoy the following video to see how our laboratory can support the research of fiber or nanofiber.
Hello, good morning. My name is Novitri Hastuti. I am a researcher in Forest Product Research and Development Center. Today, I would like to show you how our laboratory can produce cellulose from lignocellulosic material and also other nanoproducts from cellulose. Cellulose is a natural polymer. We can get the cellulose from lignocellulosic material, such as in my hand, I hold rumput gelagah biomass. How to produce cellulose from this rumput gelagah, I will show you next. Rumput gelagah, or in English translated as reed grass, is an aggressive plant. It grows quickly and push other aquatic plants that are considered more useful. However, the cellulose content in it can be extracted and utilized. To obtain cellulose from rumput gelagah or reed grass, after rumput gelagah are dried and cleaned, the pulping process is carried out through a craft method using a digester. From this process, pulp with high cellulose content can be used as raw material for paper or nanocellulose. As I told you in previous section that we can extract cellulose from rumput gelagah, and after chemical processing, using craft pulping, we can convert rumput gelagah to raw pulp. Raw pulp actually is the pure cellulose, even though still a little bit amount of lignin and hemicellulose, but we can produce nanocellulose from this raw pulp.
After getting pulp as a pure cellulose, we can extract nanocellulose using acid catalysis. In this picture, you can see we put a sip of sulfuric acid, and then the process induced by heat and speed stirrer to get nanocellulose.
One of research that I did during my doctoral course in Japan was the use of oil palm M3 food buns fiber as a membrane material for bioethanol dehydration. The fiber from oil palm M3 food buns, which has been bleached, was oxidized using tempo oxidation method to get nanocellulose. By using tempo oxidation method, this process converts selectively the primary hydroxy groups of cellulose into carboxylates, and fully individualized tempo oxidized cellulose nanofibrils can be obtained. Nanocellulose was reacted with alginate using water as a solvent and printed in Petri dish, then evaporated at room temperature. The characteristics and mechanical strength of the membrane were evaluated and then applied to a series of ethanol dehydration tests. Based on the research results, the pores of the nanocellulose membrane are effective in selecting water and are able to reduce the water content in the ethanol solution. Research of fiber or nanofibers is supported by several tools such as scanning electron microscope or SEM. Using SEM, the morphology of the fiber or nanofiber can be observed more clearly. Our SEM brand is Z-type EVO50 and is operated at an acceleration voltage of 10 keV. The following images are SEM image of agar waste fiber. Another research tool is the X-ray diffractometer or XRD. With this tool, the crystallinity index of materials, including fibers, can be known, and this data support the explanation regarding to the mechanical properties of individual materials or fiber. One of important characterization of our nanocellulose is pore surfaces, and we can use this apparatus to analyze the pore and surface area of nanocellulose. Then, after walking around our laboratory, you can see that cellulose from rumput gelaga can be converted into this paper. Amazing, right? So, keep working, keep smiling, keep learning, and never-ending working.
All my presentation, Mbak Desy.
Yeah.
I give.
Thank you very much, Dr. Novi, for your interesting and informative presentation. As we know that the natural fiber is very promising for the future development as we try to back to nature, and then how to develop all the fiber and cellulose from our nature can be used with the innovation and technology for many applications in the future. Distinguished participants, ladies and gentlemen, we already hear and see and already visit the research of each speakers, our distinguished speakers here. So now we're coming up with the session of Q&A. As we know, there's a many question already in the chat room, but at this session, I would like to invite participants. Maybe you can open mic to us directly to presenters, to the speakers, our speakers here. Maybe there's some question for you. Is there anyone want to directly ask the question directly by open mic? Here in the chat, we have many questions already. For example, from Ibu Yupi or Pak Eko Sutrisno or Pak Zulfahmi or Pak Dodi. There's a giveaway for the one that want to open mic and ask the question directly to the speakers. So maybe anyone? Okay.
Thank you.
Yeah. Who's?
Yupi.
Okay, by Yupi.
Yeah.
Please ask your question.
I have asked on the chat, but maybe it's directly. I forget for the first. For the first, maybe some people has answered my question about the silarium for the is the silarium bogoriensis open for every day. I think his answer with the video. I have the answer, but the second answer about this silarium is there the silarium come from Indonesian only or any kind of silarium from abroad? I think there is an answer. I don't know who is the answer. Yeah, but it's okay. Maybe Ibu who is the presenter, the first
Ibu
presenter,
Ratih?
maybe
Yeah.
can explain more about that because it is very interesting to me.
Okay.
Yeah.
Thank you very much, Ibu
Okay.
Yupi.
For this
Where are you
second,
from? Can you introduce yourself or your
I'm from
institution?
Bogor Botanic Garden, Lipi.
Okay.
Yeah.
Okay.
Now Brin, yeah.
Okay. No, we are the same
Okay.
house, maybe.
For the
soon.
second, for Mr. Indra. Hello, Mr. Indra. He's still young.
Hello.
I'm interested with the kind of wood that Japan used to build their house. What kind of the wood or the species that they use? Because I came from Sumatra. My parent house is built from wood too, yeah, until now. But for now, it is very, very difficult to find the wood to build the house. So now I don't know where we find the wood to build. Maybe you can explain about the wood in Japan to build the house. Thank you.
Okay, thank you, Ibu Yupi, for your question. So for the first round, I would like to invite Ibu Ratih to answer the question from Ibu Yupi, and maybe you can also ask us. You can also answer the question that which are related to Ibu Yupi question. So it's more effective to some question in the chat. Thank you. Please, Ibu Ratih.
Yes, thank you very much. So I answer Ibu Yupi's question and also another question, isn't it?
Yeah, some question that may be related with the Ibu Yupi question.
Okay. Yeah. Thank you very much, Ibu Yupi. It's nice to meet you here. I know Ibu Yupi well. So we are in the same activities in
PUI.
PUI. Yes.
Yes. We collaborate in PUI. Yes.
Yes. Okay, Bu Yupi, your question is how many the for collections? Yeah, we have more than 3,000 collection timber from Asia, from Europe, from Africa, from America, and also from Australia. We just got recent collections from Korea this month. It is 60 species of Korean timber. So we also make exchange for timber collection. So that is why we also get another collection from other countries. So you can visit us every day, and also except in the weekend, of course. If you wish to conduct a research together, or you want to just to make a study here, you can simply submit a letter to our director, and then we can we can come every day here, and also open for students. So for the final exam for students, they can do in here the final research as well. And then another question.
May I ask
yes?
first? Is it only wood from wood, any kind of tree fern, something like that?
Sorry?
Any kind of tree fern, paku?
Oh, no. We only have bamboo and also rattan. Rattan. Yeah, because it is bamboo and rattan is non-timber forest products that we also conduct basic properties research, basic property study for that, and we also from the research we develop or we produce some books with Indonesian wood atlas, and also Indonesian rattan atlas and Indonesian bamboo atlas. So only that, and also we have the fossil book, but no collections from palma and another plants. And for other questions, Ibu Desy, how can I answer? Or
yeah, maybe there's also related with Ibu Yupi question, like from Dr.
Yes, some
is
can
it the wood is all age same for the collection, something like that, and then
yeah, I try to answer all the questions. Actually, at glance questions. The second question from Indra is very good question, Indra. Indra asks about the identification of what specimen is very important for engineering field. What kind of identification of timber that will be developed? Will engineering properties be tested and identified as well, such as the strength, modularity, and etc. It's very good question, Indra. Actually, the 4D dynamic ACVT was aimed to find the tree brain or where to find the otak pohon gitu ya, and besides that we also develop non-destructive testing to predict the wood hardness and mechanical properties of standing trees by using the capacitance base, and also it is the research cooperation with Perhutani to predict the wood properties without cutting the timber. And firstly we conduct to thick to jati, and then from Ibu Niken Puji, the question is, does the sample collection including from South Sulawesi? Yes, Ibu Niken, we have 11 specimens of Calapia celebica and 6 specimens for Hopea gregaria. And then I think it will be very good if Ibu in the university also build a silarium for the endemic timber in Sulawesi. It will be very valuable because silarium also has very unique collections of timber there. And questions for Bapak Eka Mulia Alam and Ibu Fitri Garvita. Is there any limitation of age the wood sample that could be identified by ICO? Basically, we use mature and hardwood as data input. The computer vision actually is very sensitive to the pattern differences. So if we use the input data from the mature and hardwood, we hope that the user can also use approximately the same condition of timber. But we have tried to because basically the young, mature, wet, and dry wood have similar wood anatomical structure, and we also try to identify wet and young wood. Sometimes it provides a high accuracy. So yeah, you can try to identify many or several ages of wood samples, and then yeah, you can also give us your experience in using the ICO for identify many timbers. And also from Fitri Garvita, is the face of wood at all ages are the same? Yes, including the branch and also the main stem. So you can also try to learn or study the wood structure. If you can cut the stem, you can also observe the branch of the tree. And how about the wood forensic for Ecosutrisno? This is the surface from Silarium. Yes, Pak Eko, it is one of our main tasks here in Silarium. We provide wood identification testing service for the public, and also for some cases for forensics, some cases also go to the courts. So we become the expert witness. Here we also have Pak Dodi from Gakum Jawa Timur. We also have custom and Gakum in determining the validation of illegal document or also SKSH, surat keterangan sahnya hasil hutan. The last question from Dr. Zulfahmi, yeah, is the wood anatomy effective to identify the geographical origin in the timber traits? Yeah, and then compare with the DNA markers. Dr. Zulfahmi, yeah, environment influence the quantitative properties of the timber. For example, if you have thick timber from wet and dry locations, you will have there is some slightly changes of the wood structure, but mainly for the quantitative. For example, the diameter of pore, the length of the vessels, and then but basically the anatomicals is still there. So the using of wood anatomy me to predict the geographic origin is a little bit difficult because the uniformity of wood structure, even the Sorea is planted in Sumatra or planted in Kalimantan. So we have to combine with another methods. Then MACR at the moment is the most accurate one. But the K is database for wood identification. So we have to develop DNA database for all timbers from and from around the Indonesia, for examples. And then yeah, it is still quite expensive. And then also another approach is by using data forms. You can googling that. The data form is simple, but it's very expensive and cannot be used in the field. So I try another approach by using the laser-induced plasma spectroscopy. It can be identify the origins of the timber, but yeah, it's difficult to build a handy and portable one. And also in here in the wood anatomy lab, we have Dr. Kristianto, Listia, and also Ibu Tutiana as anatomy team. Yeah, we can have we can provide information whatever you need about the wood anatomy and also the wood identification, especially in Indonesia. That is all. Ibu Desy, maybe some questions.
Yes,
Miss.
Thank you. Yeah, thank you very much, Dr. Ratih. We will come back to you after we get other questions. So I saw here one person raising hand. So I would like to ask, maybe is there, before we go to Mas Indra, to Pak Indra, maybe other question directly to Pak Jamal Balfas. Is there any participant? Is it Ibu Arianti from BKSDA will ask question? To whom you want to ask question? Ibu Arianti? Okay, we will come back later. So, so is there any participant who wants to open mic, directly asking question to Pak Jamal Balfas about his research on the oil palm trunks and the technology?
I have one question.
Okay, from who? Oh, is it Pak Jamal?
This
okay.
Two
Yeah,
person.
Yes.
Yeah,
Please
we have two
chat.
persons who deliver the same question. One is Pak Indra Gunawan, the next door, and one is Pak Bedmansyah. The question is, why the lower density of timber is not classified to be used in construction? In fact, in the slide I show and I mentioned that the lower density can be used for flush door. So this is part of the component in the house. We can also use this material for other products like particle board or block board. So this material, the lower density of the timber of oil palm wood has a lower content of the structural tissues of vascular bundles, because the structural part of this timber is the vascular bundles. In the lower density woods, it contains low amount of vascular bundles. So after drying in the form of solid wood, these timber are mostly cracked and spongy. So we cannot use for construction directly. So we have to convert into other forms of panels like block board or a particle board. So we can then use this for the construction. I think that's my answer for the question. Thank you.
Yes, thank you very much, Pak Jamal Balfas, for responding the question in the chat. So we are going to Pak Indra, would like to answer the question. The first from Ibu Yupi, and then all the question in the chat room. Please, Pak Indra.
Okay, so the question for me is come from Ibu Yulianti Bramasto. How about but wood is sustainable material, but why right now many building construction using light steel material? So basically, wood still, maybe it's like the world is going to like sustainable material is like recently, and then there is still so many less research to the wood structural. So when you see the chat as well, there is still so many problems such as fire protection, sound, and then the termites, something like that. It also needs some research as well. But I think the most problem for wood structure is the cost, I think, because from concrete and then for light steel material is more cheaper than wood material. I think it's also happened in Japan. Even in Japan has so many forests, but the wood price is still almost double than the concrete price. And then the second question is come from Ibu Fitri Garvita. How high is the strength of the earthquake that wooden structure can resist? Basically, the strength of the wood is can be equal with the FC24 of the concrete. So it's quite strong enough. But for the design level, we have the level 1 earthquake, and then we have level 2 earthquake design level in Japan. It depends on the owner. For the level 1 earthquake, it's about like in Indonesia, maybe we can say easily for Scala Richter 5 earthquake. For Scala Richter 5 earthquake, there is still no damage to the structure. But for level 2 earthquake, maybe we can resist until the magnitude 7. So, and then there is no damage to the structure. But both will not like make the structure fall. And of course, it's still also the problem of price. If you want to make the structure stronger, of course, the price is also will become higher. And then the next question about how to prevent the fire and then how to prevent the termite. For the fire protection, basically for design, if we design the column using 150 millimeter times 150 millimeter, actually we cover it again using wood panel. We make it like 200. So even if it's fire, if it's burned, we still have enough section for the structure material itself. So we cover it, we make the structure more thicker than our design. And the other also, we put the gypsum to the wood structure. So we cover the structure with gypsum. But sometimes also for wood structure that will be exposed, we know that wood can be easily burned. So how to prevent it's like to put the sprinkler or something in the structure. We cannot fight the natural properties of the wood. And then for termite itself, in Japan actually, for wooden structure, it's not directly not to put to the floor. It's we put the structure a bit higher than the ground. Maybe if I can share the screen. The structure of the wood is like this. So the soil and then some concrete first. After that, we put the wood structure above. So it's not directly going to attach to the soil. So a bit to prevent from termites. And then we also paint the structure. Last from Bu Yupi. What kind of species of wood that using in the Japan? Usually in Japan we use the local wood. It's called sugi, maybe, and then also hinoki. Hinoki it's like cypress, maybe pohon pinus, and also matsu it's like pine. pine pohon pinus kah? Cypress is like cypress. Pohon cemara ya, cemara. We are using that. Basically, if we can know the material strength of the mechanical properties of the material, we can design the housing for a structure. So I think it's very important to identify the mechanical properties as well. Looking forward the application developed by Bu Ratih.
Yeah, thank you very much, Pak Indra. Is it, are you already answered all the questions? Hopefully, yeah. So once again, I would like to invite our participants. If you have any other question directly to the speakers that you want to ask directly with open mic, there will be a giveaway from the one who wants to open mics. Yeah, if there's still no open mic for the question, I would like to go to Mbak Novi to answering some question in the chat. Like here, there's one question. Wait. You already get the question, Mbak Novi?
Okay, already.
Yeah, please answer the question. Okay.
I would like to reply or respond to the question from Pak Eko Sutrisno, I think. Okay. Your object is the natural resources. Actually, this question also delivered to Pak Indra. Maybe you can give additional reply after I respond this question. So, how to make in line about the production advanced materials from wood with the growth of the tree? It just to make balance in sustainability scheme of the material process and all the utilizations. So, if I relate with my passion in nanocellulose research, actually in Japan, industrial company in paper industries already produced nanocellulose as their, how can I say, their consumable products, and they can deliver the nanocellulose produced from softwood by a very strict contract that they will provide the nanocellulose to the university in the lower price, but you have to develop more and more research about the nanocellulose. So I think it is a good start for developing the nano materials, particularly on nanocellulose in Japan. So I think in Indonesia, we can also adopt this, how can I say, this pathway maybe as Japan. But in Indonesia, I have some connection with other researchers from Indonesian Science Institute who also diligence in doing research of nanocellulose. So I think we can, how can I say, we can get the raw materials to produce nanocellulose for producing advanced material by develop our forests in certain purposes, like we have hutan tanaman energy or hutan tanaman industry, but this PlayStation can be used for the industrial production to produce maybe in the future nanofibers or nanocellulose and etc. That's all my question. That's all my response. Thank you.
Thank you, Mbak Novi, for answering the question from Pak Eko. Yeah, is there any question? Let me check to the chat. Okay, Mbak Novi is already started. Already answers. Yeah. Okay. So I would like to invite once again, if there's any participants wants to ask a question directly by open mic. We still have a few minutes time here before we are closing this session.
Desy, I have one more question from, I think it's Miss Depi.
Oh, okay. It just come up from the chat here. Okay, please,
Yeah. What is the biggest challenge for you to develop more research on nanocellulose in Indonesia? The first challenge, I think the provision of apparatus, but not only like SEM, because maybe many institutions they have SEM for analysis, but for TEM, transmission electron microscope, not we have no much institution or a very in limit number EM, and sometimes if we would like to observe the object of nanocellulose and the apparatus is broken, so that's the big challenge. And also based on my experience, when I would like to do the sonication, we still have limitation in the capacity of sonication that we use in our laboratory. We only have the small sonication with the small capacity, so it's very challenging for me to develop research in nanocellulose. But actually, the simple wish of the researcher in Indonesia to develop research of nanocellulose is sometimes we have the private company in they already I think available in Indonesia, like a pulp and paper company. They can produce the nanocellulose for commercial, because if currently all of researchers in nanocellulose, they have to produce the nanocellulose by themselves. So we have to pass the process and sonication process and so on, and it's quite hard because the rendezvous will be small. And if we would like to develop the nanocellulose in larger scale, it's the big challenge for us. Okay, that's all, Mary.
Yes, thank you very much, Novi. Hopefully the answer could fulfill the question. If Pak Eko still here, maybe you can asking if there's still more explanation from Novi or other Ibu Devi. Is it already clear, the answer from Ibu Novi? Okay, hopefully it's already answered your question. So once again, if there's any participants maybe wants to, okay, Bu Devi already give the thumbs. Okay, Bu. So if there are any participant wants to ask the question directly to the speakers, so please open your mic and the committee will give you some souvenirs if you want to open mic to ask the question. Okay, there's actually one raised hand here from Ibu Ariyanti from BKSDA, but are you there or just accidentally the raised hand icon? Okay. If there's no other question, I think all the presenters, all the speakers, our distinguished speakers here already answer all the questions that already put in the chat, that already asked in the chat. So thank you very much for the all presenters for the very wonderful presentation and all the information here. So before I give some small close statement, maybe there's some announcement from the committee. Mariani, do you have anything to?
Thank you, Desy.
Yeah, please.
Maybe the committee will contact Ibu Yupi for
okay. So the committee will contact the one that who will. Yeah, congratulations. Ibu
Thank you very much.
Yeah, super names. So, okay, distinguished participants, ladies and gentlemen, I think we already come up with the end of our session here, our session of Forest and Forest Product Innovation Virtual Tour as part of the event of the 6th Innofor of the year 2021. So we already hear and already saw the valuable information, knowledge, and also we have opportunity to visit by virtual to the research place and site. And Ibu Ratih presented on how Silarium bogoriensis become the first word Silarium collection, and how to development of automatic wood identification system to make it to facing the era of 4.0 or in Japan is already 4.1. So, and Bapak Jamal Balfas already showed us how the oil palm trunk become alternative timber with the most appropriate processing technology. And here, Bapak Indra Gunawan from Tokyo directly saw us the earthquake resistant design for the timber structure in Japan. And last but not least, Ibu Novitri shared us her research on nanocellulose membrane for external dehydration and the use of natural fiber in the future of development. So hopefully all the information here will be useful for us and bring us the knowledge. I found some interesting, I think very good quote in the internet that if you look at the history, the innovation doesn't come from just giving people incentive, but the innovation comes from creating environments where their ideas can connect. I think it's already represent for all the presentation that made wonderfully amazingly by all the 4 speakers in our session today. So on behalf of the committee, I would like to express our gratitude to all distinguished speakers for the presentation, wonderful, interesting, and then it's very useful for us and also to all participants. Until here, we still have 100 more than 100 participants in the session. So in the future, hopefully we can have another innovation and technology as well in this topic and this session as well. And then last but not least, I would like to say stay healthy and stay happy and keep on, like Novi said, keep on moving, keep on working, and don't forget to keep on happy. And before we end of this session, maybe we will take a group photo session, Mbak Aryani.
Before that, maybe I would like to inform that.
Yes, please. Okay. Silakan, Mbak.
I just want to remind that tomorrow will be a plenary session of stream 2 and parallel session. So all participants do not forget to join tomorrow.
Yeah,
okay.
Thank you for reminder, Aryani. Yeah, the 6th Innofor 2021, we have 2 days session, and then we still have interesting and amazing presentation from different topics from our center here tomorrow. So everybody keep on posting and then look for the interesting topic on stream that you want to join. Yeah. We will have the photo group.
Okay.
Variani? Okay. So please, Bapak Ibu, open the camera so we can have all your face or bring some reaction also.
Okay, slide 1.
Yes.
1, 2, 3, cheese. Yes, my slide 2. Next. 1, 2, cheese. Slide 3. Okay, thank you. Slide 4 and 5. 1, 2, 3. Cheers. Thank you. Okay, thank you.
Yes, thank you very much, ladies and gentlemen, distinguished speakers and distinguished participants. On behalf of the committee, I would like also to apologize if there's any inconvenience during this event session. And from me, myself, if there's some mistake or some inconvenient words or something, so I would like to please apologize. And once again, thank you very much and keep healthy, keep happy, and see you in the next session in this INAFOR. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih Bapak Ibu, speakers, dan semuanya.
Terima kasih.
Bapak Ibu.
Mbak Novi, terima kasih semua.
Thank you all presenters.
Okay, Bapak Ibu, all participants, we will end meeting. The committee will email your certificate in a few days. Okay.